Okay, store A has 34% of the sales and store B has 66% of the sales. Let's write down that information. That means that probability that a sale item is from store A is 34%, and the only other possibility is that it comes from store B, and I know that because these total 1. So those are the only two possibilities. And now there's some more information. Store A has 34% of sales, 5% of which are defective items. So what you're being told is that if, so given, in other words, that an item came from store A, the chance that it's defective is 5%. In the case of B, 1% are defective. Okay, so with this information, if it came from B, 1% are defective, and then the question in the last sentence is what is the probability that a defective item came from store B? In other words, you know it's defective and you want to know the probability. So it's given defective to you. What's the chance that it's from store B? Okay? Now, since this is what you want, but you have the reverse, you should feel immediately that this is going to require Bayes' rule. What I've written here is not Bayes' rule. This is just the relationship between the conditional and the probabilities, right? This is like a definition of the conditional probability. So it's just showing that out of D, so that's where that comes from, out of D events, the chance that it's also a B event. That's what the conditional probability means. In the case that there's independence, this all becomes just probability B, because these would be multiplied and then that would cancel like that, leaving B. So that's if they were independent. But this is not the case. You're not told they're independent. So what do? Well, we have the reverse conditional probabilities, right? We have all this information here. And from this information, we can re-express these parts as conditional probabilities. So applying Bayes' rule, I'm going to do this step by step. The top, we're going to write in terms of the information we have. So we have information conditional on the stores, right? So I'm going to rewrite the numerator like this, right? Where does that come from? Well, the same logic as where this expression came from. What about the bottom? Well, the bottom, the denominator, to get that, the probability of D is the probability of D and being from store A, or, in other words, plus the probability of being defective and being from store B. So this is how Bayes' rule works. This expands just like the numerator did, okay? And this other one expands just like the numerator, exactly like the numerator did, to get the denominator. All right, so this is an application of Bayes' rule the information. Notice the information you were given, so for future situations you know how to solve this problem. You're given information on the reverse conditionals to what you want. If you plug in the information here, you should get the answer C. In this problem, we have to begin by presenting all the possible arrangements we might see of flipping 3 coins. And here they are. If 3 tails occur, the player wins $3. So this outcome is worth $3. If 2 tails occur, the outcome is $2. If no tails occur, the player loses $3. And if 1 tail occurs, nobody wins anything. Let's try and present the outcomes here and the probability of the outcomes here for the expected value or the expected winnings of the games. So rather than using the outcomes as 0, 1, 2, 3, we're going to use the dollar outcomes as negative $3, 0, 2, and 3. So that's what goes here. Negative 3, 0, 2, and 3, with the probabilities associated with the probable outcomes, where we understand each of these 8 possibilities are equally likely. So this one has a probability 1/8. These 3, HHT or HTH or THH, have the probability 3/8. This one has the probability 3/8. So, and the probability of 3 tails has probability 1/8. So using that information, I complete the probability distribution where all these probabilities sum to 1. And now I'm ready to calculate the mean. How do I do that? It is a matter of calculating the weighted mean. When you do that, you get negative 3 times 1/8, 0 times 3/8, 2 times 3/8, and 3 times 1/8 are represented here, all added together for the weighted mean. These cancel, the second term is 0, so your answer is 6/8. 6/8 is also 3/4 or 75, in this case, cents. The answer is D.